Welcome, ladies and gentlemen. Good morning. May I have your attention, please? Thank you. So as you know, you'll be having your final exam during next class period, the final class period of the regular semester. That'll be Thursday the 14th. Okay. So what's on your final exam? Well, the solving portion includes a mixture of those problems that you've encountered on your solving equations review number 1 and the thing you picked up today, solving equations review number 2. In fact, it looks exactly like those on your final exam, but with different numbers. So let's go ahead and jumble them up and see if we can't find our inverse operations to reverse and undo our forward steps in order to solve for x. So number 1, overall, looks like a power function. We know we can solve power functions by, well, undoing the exponent. How do we undo a fifth power? Raise both sides to the reciprocal exponent. And so to undo a fifth power, we would raise both sides to the 1/5 power, the reciprocal exponent. And so to undo a fifth power, we'll raise both sides to the reciprocal exponent. Because my original exponent, right, is a positive integer 5, you could also consider this as taking the fifth root. Either one is correct. So I know I get x alone by taking the fifth root, and we could get a decimal approximation for that, or we could leave this as 27 to the 1/5 power, or the fifth root of 27. Each are correct and exact. That's different than number 2. In number 2, I'm not going to raise both sides to the reciprocal exponent because my variable is in the exponent. It's 5 to the x, which is very different than x to the 5th. This is an exponential equation, and we took a long time figuring out how we could solve exponential equations exactly in algebraic. So we can't raise both sides to the fifth root. We can't raise both sides to the 1/x power. What are we going to do? We're going to go ahead and consider if what my output, 27, is a perfect power of my base 5. Is 27 a perfect power of my base 5? No. Can I use my half sheet to solve this? No, but that's okay. We've got a tool that allows us to get variable expressions down out of the exponent and down on a level playing field where we can solve for them. So what are we going to do? We're going to take the log of both sides. We can take the log of 5 to the x and the log of 27. That's our strategy, right, that we'll use to get a variable expression down in the exponent. We must first take the log of both sides as is. Then we're able to utilize the log power property, which says we can take that exponent and bring it down in front as a constant multiplier. So we'll take that x, we'll do the log of a power property, which allows us to bring down that x as a multiplier in front, times log of the base 5 equals log of 27. And now I can solve for my unknown x using division, right? Now I've got x on the ground floor. I can simply solve by undoing that multiplication. What undoes multiplication? Well, division. So we'll divide both sides by log of 5 and be done with it. So my exact answer is x equals log of 27 divided by log of 5. That's it. Raise your hand if you already had that. So who remembered to take the log of both sides? A couple of you remembered. This is exactly like one of the questions on your final exam, just with different numbers. And so you have to be able to solve an exponential equation where my output is a non-perfect power of the base. We can't use my half sheet to solve. We've got to get our properties of logarithms involved. Awesome. Let's go ahead and take a look at the next. 3/2 x equals 8 is very different than x to the 3/2 equals 8. Again, we're trying to use the same numbers, but rearrange them to get at the difference between my inverse operations by solving steps. So here we go. I can get rid of that fractional multiplier if I multiply both sides by the reciprocal. Remember, dividing by 3/2 is the same as multiplying by 2/3. And so the best first step, in fact, the only step needed to solve this one, is to multiply both sides by 2/3. Then I get x alone. And I'll get 8/1 times 2/3 would be 16/3. And that's exact. Once I change that to a decimal, right, 0.33, I start losing accuracy. And so I'll go ahead and leave this on my final exam as x equals 16/3 and box it, right? That's totally fine. Contrast that with your inverse operation for number 4. Number 4, like number 1, is a power function, right? x to the 3/2 power equals 8, so we can raise both sides to the reciprocal exponent in order to solve for x. Again, this is a one-stepper. We'll purposely raise both sides to the reciprocal exponent in order to solve for x. What's the reciprocal of 3/2? Well, that's 2/3, and so we're going to raise both sides to the 2/3 power. Unlike number 1 where we had to stop, we can continue simplifying x equals 8 to the 2/3, right, without a calculator. What? We can do 8 to the 2/3 without a calculator? You bet your boots. Recall that we can apply the denominator of this rational exponent as an nth root first to reduce this base to a smaller number and then raise to the numerator exponent, that squaring last. Let's go ahead and see what I mean. So we could rewrite this and work from the inside out and rewrite this 8 to the 2/3 as 8 to the 1/3 and then all squared. Notice how this denominator of my rational exponent 3 is telling me what kind of root we're taking. And so we know the cube root of 8 actually equals 2. So this portion is just 2. And then we can raise to my numerator exponent the squaring last. So my final answer would be x is 2 squared, which is x equals 4. So x equals 4 would be my final exact answer. And we got that, again, by evaluating a power with a rational exponent by considering that denominator of my exponent first as an nth root and then raising to my numerator exponent last. What questions do you guys have about number 4? Let's keep the party going. Recall that our special equations involving multiple solutions, right, arose from either absolute value equations or squaring equations. In each case, right, we want to be able to solve and make sure that you're not getting half the answers, but all of the answers. So what do? Well, we could go ahead and do my forward steps and then reverse and undo. So my forward steps in this absolute value case, if I were to cover up the equal sign and plug in something for x, the first thing I would do is subtract 4, and then I would take the absolute value bars. So I'm going to reverse and undo that. How do I reverse and undo absolute value? That's my favorite expression. Break it up. Break it up. That's where I get rid of the absolute value bars by setting the quantity inside equal to the positive and negative distance number, because there's two numbers that are a given distance away from 0. So I'll go ahead and call it break it up. Break up the bars. And then lastly, add 4. Let's go ahead and do that. So if x minus 4 equals 9, then my first solving step, since the bars are already alone, would be to break it up and set it equal to two different equations. One where my quantity inside is equal to the positive distance number, in this case 9, and one where the quantity inside x minus 4 is equal to the negative distance number, the opposite of 9. 9 and negative 9 are the two numbers that are a distance of 9 steps away from 0 on the number line. So we don't change the sign inside the absolute value bars. We don't do an x plus 4 anywhere. We take the quantity inside and we set it equal to the positive distance number and the negative distance number. Now I can finish it out with my final solving step, add 4 to both sides. So x equals 9 plus 4 is 13. X equals negative 9 plus 4 is negative 5. And before I box them, let's go ahead and check. So 13 is the original. 13 minus 4 is 9. Absolute value of 9 is still 9. So that works. Let's try x equals negative 5. Into the original forward steps, minus 4 is negative 9. Absolute value of negative 9 is still 9. So big. So it looks like each of these work, and we have multiple solutions. So again, on your test, absolute value equations are a candidate for multiple solutions, and so are number 6, squaring equations. What? Well, they're, again, just like there's two quantities that are given distance away from 0 on the number line, there's, right, two numbers such that when squared equal a given result, so long as that result is positive. So is my squaring quantity set equal to a positive number? Yes, so there's going to be two different paths that we can go by in order to solve. Again, I'll go ahead and start with my forward steps. So my forward steps, if I were to cover up the equal sign and plug in something for x and evaluate that expression like in middle school, first step is, again, subtract 4. Next step is square it. So to reverse and undo that and get my solving steps, we'll undo a squaring by considering the positive and negative square root, because there's two quantities such that when squared equal 9. So positive and negative square root. Again, if you're undoing an even integer exponent power, you need to consider both the positive and negative root when you undo that. And then lastly, undoing, subtracting by 4 is addition by 4. Which we should make that look just a little bit better in the last one. Again, striving for PDFable, comma baby. We want PDF. So let's go ahead and apply the solving steps. First step, positive and negative square root. So I know that x minus 4 is equal to the positive and negative square root of 9. Sometimes this will reduce, sometimes it won't, but either way, it'll be able to be broken up into my two different paths, just like we broke up my absolute value into two different paths. What are they? Well, they're x minus 4 is equal to the positive square root of 9, in this case 3, or x minus 4 is equal to the negative square root of 9, which is negative 3. Now I can finish it out in one step, add 4 to both sides, x equals 3 plus 4 is 7, x equals negative 3 plus 4 is x equals 1. What? I don't believe it. 1, let's put it in the original and check. So 1 goes in for x. 1 minus 4 is negative 3. What's negative 3 squared? That is negative 3 multiplied by itself. That's negative 3 times negative 3 is positive 9, so that checks as well. 7 minus 4 is 3. 3 squared is 9. Both of these are multiple solutions. What questions do you guys have about your solving steps? Again, central theme throughout the course, right? We'll return to solving equations and apply it in context next semester as well. Let's go ahead and remind you about our linear functions. So slope-intercept form, we use for number 1. We use x and y intercepts for number 2, and then it looks like number 3 is a special. So everybody, let's keep going with your review. 2x plus 3y equals 6. If I wanted to rearrange this, I could subtract 2x from both sides. Whoops. Negative 2x plus 6. And then divide everything by 3. So we'll divide everything by 3 to get slope-intercept form. It looks like negative 2/3 x plus 2. Let's go ahead and tell the class the y-intercept. So y-intercept b, when I call on you. If we're using slope-intercept form, its utility is its ease of graphing. Right? So what's my y-intercept for the right equation? Negative 2/3 x plus 2. Eric? My y-intercept of negative 2/3 x plus 2. No, that would be my slope of the line, right? 2 is my y-intercept. My initial value, my start value is the 2. Thank you. So I'll go ahead and plot that. Now I'll count out my slope value. And Eric just stole the answer to my next question for someone else. So you're lucky. Now we're going to count out my slope number, negative 2/3, from this down to over 3. Down to over 3. I can even go backwards so long as I then went up. And we'll go ahead and connect those into my line. So we can sketch a graph from slope-intercept easily by plotting the y-intercept and then counting out my slope number as a fraction rise over run. In number 2, we can find x and y-intercepts easily as well by plugging in 0 for x and solving for y to get the y-intercept, or plugging 0 in for y and solving for x to get the x-intercept. In the first case, let's go ahead and find the x-intercept by plugging 0 in for y. I know that the x-intercept will be given by the point x comma 0, because when I have an x-intercept, the y-coordinate has to be 0. Let's plug in 0 for y and see what we get. So 2 times 0 is 0. So I'm solving the baby equation 4x equals 6. I'll solve that by dividing both sides by 4, and I get 6/4 or 3/2. So it looks like my x-intercept is 3/2 comma 0. That's the same as 1.5 comma 0. My y-intercept will be gained by plugging in 0 not for x. I'm sorry, not for y, but for x. Uh-oh. So I'm going to go ahead and plug in 0 for x and solve for y. So I get 2y equals 6 divided by 2. 6 divided by 2 is 3. I'm getting 0, comma 3 for my y-intercept, and we'll plot that. We'll now go ahead and connect those, and I've got my line. Awesome, awesome. What questions do you have about your x and y-intercepts? And there's several on your semester review packet that you can work on as well. And lastly, I've got the special x equals negative 4. Recall that's the line that connects all the points that share the same x coordinate, an x coordinate negative 4. So if I considered some points on there, it'd be like negative 4 comma 0, negative 4 comma 1, negative 4 comma 4, negative 4 comma negative 6. If I connect all those points, what would the line look like? This looks like a vertical line. A vertical line is an x equals equation. So I get a vertical line that connects all the x coordinates. All the points rather that share the x coordinate negative 4. What's the slope of any vertical line? Right? How much it moves, how much you rise or fall as you move along from left to right? Adam? Undefined. The slope of a vertical line is undefined. The equation is not undefined. The equation is x equals a number. X equals negative 4. The slope is undefined. Right? The slope is undefined of a vertical line. Awesome, awesome. Okay, lastly, we can do our matching. On your final exam, just like your review packet, you'll have several matching questions based on the equation and changes to that equation. Consider the graphical effects that has on your parent function. So, in your parent function, y equals x squared, we go out from our vertex 1, up 1 squared is 1, out 2, up 4, out 3, up 9. So, a parent function graph, if my scale on these is 1 tick mark for 1 unit, it looks like A is my parent function. So, that first top left graph would be y equals x squared. Now let's consider what happens if we put a multiplier in front. A negative sign is going to make it upside down, and a multiplier greater than 1 is going to make it steeper. In fact, negative 3 would be 3 times as steep, x squared, versus a 1/2 is going to make it less steep, more gradual. So if I had the negative 3x squared, b must be the bottom right one, because that's steeper and upside down. D must be the bottom left one, because that's upside down but less steep. Everybody see that? Negative 1/2 is going to be less steep for my multiplier times x squared. And then lastly, the 2 must be right side up still, but twice as tall. When I went out 1, I didn't go up 1. I went up 1 for my vertex. I went up 2. That's twice as much. There's my multiplier of 2. And so C must be my top right. So A, C, D, B, left to right. Questions about your transformations, that negative multiplier, what it does? So let's take a look at the next one. So A, B, C, D, this is my hyperbola function. When we did our function calisthenics, back in Unit 1, we did our branches were left palm, right, up in quadrant 1, and then right palm down in quadrant 3. So what happens to that graph when we start doing transformations? Well, if we put a negative sign, it's going to flip. If we put a negative 3, it's going to get taller. If we did a 2, it's going to get taller. If we did a 0.3, it's going to get shorter. It's going to be scrunched in. So let's go ahead and see if we can eliminate some of our choices. My regular parent function does not appear. So let's go ahead and see it twice as tall. I got to go C is top right because it's the same orientation but twice as tall, versus same orientation but scrunched, right? D better be down here. Now let's go ahead. That's supposed to be a D. Don't know what that looks like. There we go. Now we'll go ahead and do opposite orientation. Negative sign is going to flip from quadrant 1, 3 to flip quadrant 2, 4. So let's go with quadrant 2, 4. Taller. Quadrant 2, 4 looks like B is the first one. And same steepness, but opposite orientation looks like A is the last one. So once again, let's try it. I get B, C, D, A. B, C, D, A. You guys good? Awesome. Which brings us to our exponent review. Please evaluate non-calculator, no problem. I can evaluate an expression that has negative exponents by rewriting with the reciprocal of the base raised to the positive exponent. So 8 to the negative 1/3 is the same as 1 over 8 to the positive 1/3. That is, take the reciprocal of the base and raise to the positive exponent. And I know that the cube root of 8, right, 8 to the 1/3, is the same as 2. So my final answer would be 1 over 2 is 1/2. Olivia?
Do you have to give, it would just be for 1 anyways, but do you have to give the 1/3 to the...
Technically, yes. If my base were 2/3, I would rewrite it as 3/2 to the, all to the, both top and bottom gets applied, yes. But knowing that my numerator was 1, I just went ahead and flipped it. But yes, you're right. Base to an exponent means multiply the base by itself the number of times the exponent says. So number 2 is the easiest one. It's just negative 4 times negative 4 times negative 4. We know that negative 4 quantity cubed is equal to negative 64. And that's for my half sheet. So far, we're rocking. We're rolling. And now we're ready for number 3. So Olivia asked me wait a minute. Doesn't the numerator and the denominator get raised to the exponent? Absolutely right. So 4/25 all to the negative 3/2 is the same as 25/4 all to the positive 3/2. And we know now that, right, 25/4 to the positive 3/2, I'm going to go ahead and purposely apply my denominator of my rational exponent first as a square root. So I'm going to go ahead and work from the inside out and do 25/4 to the 1/2. And then raise all of that to the numerator exponent, that's 3 last. And so let's go ahead and do the 1/2 power, that's a square root first. That's the same as the square root of 25 is 5, over the square root of 4 is 2, and I'll raise that to my numerator exponent, 3 last. That means my final answer is 5 cubed is 125, over 2 cubed is 8. I get 125/8 for my final answer. Take a look at number 4 and number 5. Are they the same answers or different? It'd be pretty sweet if they were the same answers, but they're not. What? Is there anything raised to the 0 power equal to 1? Yes. However, the order of operations dictates that only the factor directly next to the exponent, in the absence of parentheses, gets raised to that exponent, which means that number 4 is positive 4 raised to the 0 power first gives you 1 and times the negative out front last. So guess what? Number 4 is -1, and I wrote that again with parentheses as optional, just so you can see we have to apply that exponent first. So -1 is number 4. Contrast that with number 5. Number 5 is absolutely positive 1. Flip the base, raise to the positive exponent, 3 to the 4th, 81. And we're 1 to go. 3 to the -2 times 3 to the 5th. We can go ahead and apply my properties of exponents. When I multiply two powers together that have the same base, I can simply add exponents. So this becomes 3 to the -2 plus 5. Or 3 to the 3rd. I look on my hash sheet and find it. Contrary to popular belief, that's not 9. That means 3 times 3 times 3, and that's 27. Awesome. Who gets raised to the exponent? In the absence of parentheses, only the factor right next to it. Here it doesn't make a difference because of the cubing in terms of the answer, but the order of operations is important. This is really like this. So you don't have to write this step, but this is really negative, right? Opposite of, and then 27 1/3, which means this is opposite of 3. That's different than number 9. Number 9 is opposite of 6 to the -2. Now it makes a difference because only the 6 gets raised to the -2 power. So I have this negative hanging out front, which means 6 to the -2 is the 1/6, the same as 1/6 to the +2, and that's why I get -136. Number 10, 3 to the -1 all to the 4th is the same as raising a power to a power. My shortcut operation with exponents is multiplication. So first step, rewrite without parentheses. This becomes 3 to the -1 times 4 is -4. I know that 3 to the -4 is the same as 1/3 to the +4, and I know that's 1/81st. A quotient of powers can be simplified by taking top exponent minus bottom exponent, so long as the powers have the same base. In this case, it's both 10. 10 to the 3rd over 10 to the -2 is the same as 10 to the top exponent minus bottom exponent. So 3 minus the -2 is the same as 10 to the 5th. And so I know that's 1 followed by 5 0. Let's see what that looks like. 1, 2, 3, 4, 5. Looks like 100,000. My goodness gracious, 100,000. And lastly, the square root of 18. I'll go ahead and scan my hash sheet, and I'm looking for perfect squares that divide evenly into 18 without a remainder. And I find one. It looks like 9 divides evenly into 18 without a remainder. So I'll rewrite that 18 as 9 times 2. Also, I can take that perfect square that's hiding inside of a square root and rewrite that as an integer factor out front. What's the square of 9? That's 3. The square root of 2 still remains. Can't simplify that. So my final answer would be 3 times the square root of 2. What questions do you have about our quick and dirty exponent review? All notes, make sure you have plenty of time to work on your Unit 5 quiz. So for that to happen, quick reminder, our room is 2203. That's right next door to Mr. Vestbach's room. So 2203 is our room. 2203 is right next door through this wall, Mr. Vestbach's room. So you'll come to the same hallway. You'll just come in the door right before this classroom. Bring your completed review packets, pencils, and a calculator. Please make arrangements with a friend, right, who's taking a different math class to borrow their calculator because all 4 of my sections are taking at the same time, so I'm not going to have calculators to lend out to people. Make sure you make arrangements ahead of time. Don't forget, tomorrow night is the final exam study review night from 3:45 to 5:15. Come for a little while, 15 minutes, 20 minutes, or stay for the whole time. You can ask advanced algebra teachers, advanced algebra questions, bring your review packet. That's a great opportunity to take advantage of. And of course, Thursday is part 1 of our non-calculator exam. Part 2 is the Tuesday, part 1. All right, guys. What's on your non-calculator portion? You've got 12 solving problems that look exactly like your solving equations review, worksheet number 1 and worksheet number 2 that you picked up today. Caitlin?
I just have a question. Tuesday's the 19th.
Yep.
Is it on Tuesday?
It's on Tuesday.
Is this
Oh, I'm sorry. Yeah, the 19th. Absolutely. Sorry, it was right on the last sheet, and then wrong on this sheet. Thank you very much, Caitlin. So that's the 19th, guys. Tuesday, first day of final exams, fourth block time slot. Thank you, Caitlin. Everybody, please note that change on your sheet. Tuesday the 19th, and we already had that in the last packet, though, right? Awesome. 4 points from function table graph. 11 points from exponent rules that we just did. Linear equations, slope-intercept graphs like we just did. Graph matching like we just did. And so your basic breakdown for your non-calculated portion on Thursday is as such. The last thing we need to do for our Unit 5 is get you a stamp count. And so everybody right now, you need to go count up your red marks and count up your blue stamps from worksheet number 2 and get a single total 9. You're going to put that on top of your worksheet review number 5. So you're going to get an infinite campus score on top, and you're going to get a circled stamp score. And your stamp score comes from your bell work days and your worksheet number 2 days. Now, if you look at your bell work days, day one there was a substitute. And so what we need to do is go ahead and find day 1 and see if anybody got a stamp for that on day 2. I'm going to pause the recording.